2.7 done. Okay, we're going to work on 2.7. It's only one bid problem at the end of 2.7 in the application section. So on page 235 and 236. And they start off by giving us a function. It says can be used to model the population of the US in millions of people based on the number of years since 1900. So that's important to know for the table. Identify the variables and parameters to this equation and describe what the significance of each is in terms of population. So we have variables. X and Y. So X is years since 1900. And Y is your population after X years. And then we have our parameters. A is our 81.15, and that's our y-intercept. So in 1900, we started with 81.15 million people. Can you guys see the million people? Until everybody gets that challenge. And then B is 1.013. That is our growth factor, right? Our multiplier. And our relative change is equal to B minus 1, which is 1.013 minus 1, which is 0.013. And because it's positive, it tells us that we have a 1.3% increase each year. So it's important to be able to turn that that growth factor into the relative change, so you can see if it's an increase or decrease. And now I'm going to send you the Desmos. It says use the function to complete the table. So we're going to go to Desmos, put in our equation, fill in the table. Yada, yada, yada. And again, I'm going to copy it and I'm going to do it twice so that one can be my slider and one can be my table. That's all. And then once I do my table, I can hit the magnifying glass and I'm gonna zoom out. Excuse me, my magnifying glass did not do a good job because it really doesn't show very exponential here. You really have to zoom out for it to see exponential, because it's only a 1.3% increase every year, right? So it's pretty small. So the table, they want it to be 0. 20, 40, 60, 80, and 100. So go ahead and fill in your table. I'm gonna go back to my paper. Did everybody get their table filled out using their Desmos?
Okay, when I am trying to do mine,
Mm-hmm.
and you said copy and then put it down in the next box, so you can do the table.
Mm-hmm.
I can go over it and copy it, but when I go to paste it, it doesn't say paste. What am I not doing?
Did you right click?
Yeah.
If you do Control and V, it automatically pastes. That's just the shortcut.
Oh, gotcha. Okay.
I always use that. The right click should let you paste, but
Yeah, it's not correct. I mean, I do that at work all day long, but that's weird. Okay.
yeah, I've gotten really good at Control copy and Control paste.
Oh, that control copied something, but it wasn't that. Okay.
Sometimes if I move my mouse, it doesn't copy it.
Mine didn't fill out right.
Yours didn't what?
Fill out correctly.
Did you do it to the exponent of X or times X?
Oh,
What did yours look like?
Let me show again.
okay, I gotta get you back.
And then
on
I can see if I did it right.
Sure.
Well, that's what I did. My X is up, not down.
You have
So-
81.85.
And I got 0, 20. I got -2.
Yeah, you have to replace your X values with the ones that are in the table.
But my numbers aren't changing. My numbers are staying the same.
Did you go up and make the? What do you mean your numbers aren't changing?
You have an N in your little circle. I don't. Why is that? What did I do different?
No, that's just a graph symbol.
I have like the bowling ball. Yeah.
Mine's just not wanting me to copy. Not copy.
Darla, your numbers over here in the X, if you click on it, you should be able to change those numbers to whatever you want.
Yeah, that's what I'm doing right now.
Okay.
I'm
And
just
changing
typing
the
mine.
When you change your X's, Darla, is it changing your Y column?
Nope.
No?
Nope. That's why I said I don't know what I did wrong. And
Okay. I'm going back to my original thing.
Yep.
Oh, I see it.
What'd you do?
I didn't add that little X. Well, let's see if it'll fix it. Well, I added that little X,
Mm-hmm.
but I still,
Your X has to be in the exponent, so you have to hit shift and your 6 key to make it go in the exponent.
right.
Did that work?
I'm getting there. Yes.
Yay.
295, 28. Yep. And I see my little red line.
Yippee skippy.
Boy, I
Yay.
really gotta shrink that in.
Okay. And then I'm gonna go back to my paper and see if you ladies can fill in. I'll be right back. I'm gonna go that way. See if you can fill in 3 and 4. And I'll be right back. Ah.
Okay, this, so this is growth, so it's exponential, right? Because it's going up. It's just slow. The population was
Yeah.
growing by, the population was going by what she said was 1.3% each year. I want to see where she came up with the 1.3% though. Growth factor and relative change. Oh, that must have been it. Okay. Zeros. She said do 3 and 4 or just 3?
3 and 4, but I'm working on 3.
Yeah, I think 3 illustrates exponential growth because it's going up, it's increasing. And the
Population was growing by what percentage each year?
she gave us the 1.3% back on question number 1.
Oh,
And she writing all that stuff down, it came out to 1.3% increase each year. But I guess we could do that by doing the relative change. I'm writing these numbers down off my graph on the book. Yeah, I can't see.
So you got your numbers from the table?
That's what I'm writing down on mine because I was trying to, I'm writing them down on the table. I'm writing them in my book. If that's what you're asking.
Did they not come up on your table?
Yeah, they did, but I'm writing them
Oh.
down in the book too.
Okay, just want to make sure.
Just so, yeah, just so I have something to reference when I have all my notes in the book, and then this will make more sense.
Mhm.
So I have a question though. For 3, the function f times x, the 81.5, and then the 0.13 was, or 1.013 was relative change, illustrates that exponential growth and the population. And the population was growing by 1.3% increase each year, correct?
Yeah, good job.
Okay, but I had the 1.3 because that's what you gave us on the top, but I'm not quite sure how you figured that one out, because,
Okay. Let's go back up here. at the
okay,
top. It says relative change.
right,
So your percent increase or decrease is by taking B and
okay,
subtracting 1. So B is 1.013. Subtracting 1 is 0.013. And then as a percent, it's 1.3%.
Gotcha. Okay. Can you leave that so I can write that down? I know you're writing this down, but I want to like see it all together so I understand it.
I'm grabbing something.
Darla, you're getting that?
I'm glad you asked that one because I was like, huh?
Yeah.
Letters and numbers don't mix. Are you working on your hey Carter? Are you working on your unit 2 thing?
Yes. Yeah.
What are
Slowly.
you watching?
Take out my contact.
A stock called Ethereum. It's kind of like in the Bitcoin stuff. Because my husband's, because we're actually investing in it, kind of. So we're watching the Ethereum stock.
Oh, cool. I'm watching Coca-Cola.
So I mean, we got to watch it anyway. So then I watch that.
Yep.
Okay.
Okay. No.
Okay.
Okay. Sorry about that. I had to take out my contact. Okay. So everybody sees where I got the 1.3%?
Yes, because B is the growth factor,
Mm-hmm.
right?
Mm-hmm.
Then you have the 1.013, which is your rate of change, right?
No, 1.013 is your growth factor. That's what your B.
Growth factor. So okay, so the rate of change was,
Your rate of change is the 0.013. after
okay.
subtract
Okay.
1. Mhm.
Okay, the growth factor. So B is 1.013, the growth factor. Okay.
Hi, Carter, you had some questions? So number 4 says, the model that we got here was obtained using official data from for every census from 1900 to 2010. The census is every 10 years. It's not great, but that's what they did. So it says, use your model to predict the population in 2015. Then find the population of the US in 2015 online and compare it to your result. So the model prediction, how are we going to find that for 2015?
Can you just, well, this started in 1900. Wow, you'd have to go up quite a bit to.
Mm-hmm. So what would our X be?
Oh, okay, well, 1900, so that'd be 2000 for the bottom of the answer there. Well, I went up to, yeah.
So 2015 minus 1900 is how we're going to get our X value. You have to subtract away your base year.
Gotcha.
So X is going to equal 115. So going to Desmos, I'm just going to go on my table and just put 115, which is super awesome that we can do that. And our model predicts 358.4 million people. And then online, I already looked up the actual 2015 population. And I'm going to go back to my paper here momentarily. So we came up with excuse me, my model prediction, and then the actual population was 320.88 million. So how did we do on our prediction?
You were under, or no, ours was over.
Yeah, so we
Yeah.
over predicted. Yep. So let's just put we over predicted. Remember, we did some residual stuff the other day.
Yes.
Yeah. Everybody's moving along. So we can flip our page to number 5, and it says, what do you think your answers to question 4 say about population growth in the 21st century?
So are we doing like the answer from Desmos, or we're just supposed to put down that we?
It's asking us, so looking at what happened, this is what our model would predict, but it really didn't ever make it to that, right? It only, the actual population was only 320. So I would say it says it's actually slowing down. It's not still 1.3%, right? Because it didn't actually make that prediction.
Okay.
So I would say the growth is slowing down a bit. I definitely think it's less than the 1.3% that they had suggested at first. The number 6 says, well, what if we use only more recent data? So they kind of go through, you can read all that if you want. It talks about how the census isn't super accurate, which is not, because people don't always fill it out when it's, sent at your house. That's a choice. So they used some Worldometers as a website that they say is actually a little bit more accurate anyway. And so we have a table here of data from 1990 to 2010. So this time our 0 year is 1990, not 1900, which is good to acknowledge. Use the data to find the exponential function of best fit. So back in like lesson 2.5, we did the line of best fit, right? With the tilde, the Y1 and the tilde. We're going to do something similar, but now it's the exponential function of best fit. So exponential function of best fit. So we can't put years in because we said they're too big. So that's why we have years after a base year, and 1990 is our base year. So that's 0. So 2010 minus 1990 is year 20. That's how they get this column here. That's going to be our X1. And then our population in millions is going to be our Y1 in Desmos. So, and I'm going to start a new link here in a table, and I'll put these in if everybody wants to wait a minute. I can put these in and send you the link real quick, and I'll send it in the chat. Oh gosh. What the heck? Maybe I should not be the one doing this.
Well, if you shouldn't be, we're all gonna be done.
Okay. So, and did I share my screen? Oh, no. Okay, so I'm going to send this link and I'm putting it in the chat so that you folks at home can click on it and your data should be there. So we're all using the same data. Did your data pop up okay?
Oh, I thought you said for us to not do anything yet until you get yours done. So I didn't do
Oh, no,
it.
I did. I copied it and I put it in the chat link.
Oh, gotcha. Oh, okay. So that's what I've never done your chat link before here. Okay.
We go to chat and I put a link in there. You should be able to click on it. It should take you right to the same data set.
Okay.
So I'm showing my paper again because I want to show you what to type to get an exponential model of best fit. So you're going to type Y1 because our data is in X1 and Y1. So that's Y1, not Y11. It's Y1, Y1, tilde, and then we're going to type A, and then parentheses B, and then the exponent is X1. So Y tilde A times B to the X1.
Okay.
And just a suggestion, as you're working in Desmos, you could be saving lesson 2.7 up there if you want and save your own graph. And then you've already got the Y1 tilde A times B to the X1. Then you can always go back and use that when you're doing worksheets where it's an exponential model, right? Or you could save it as exponential model, exponential function of best fit. And then you'll know, click on that one and that's where your model is.
Okay. I'm gonna do mine right now.
The other thing that you have to do, I want to mark is there for that correlation coefficient to come up that we like that tells us how great our fit is. Remember back from linears, we had that R and the R squared. We need to check in exponential. There's a box that says log mode. You have to check that box. So I'm going to go to my Desmos so that everybody can see my Desmos. So in Desmos, I'm typing Y1 tilde A, no, A times B to the X1. And then notice I only have an R squared. So once I hit the log mode, it gives me the R.
Oh, okay.
So my equation, my model is Y equals, my A is 255.06 times 1.0104. We'll round that to the X.
Okay, I tried to, would you say I had to hit the log mode on that one? Because I have that in there and I'm not seeing where my log mode is on.
Did you do a tilde?
Yes.
Did you do a Y1 and an X1?
Y1, I did Y1 tilde A times B and then X1. And then I hit enter and it has range. It looks like statistics range. And then
Oh, no,
what did I not do then?
I don't know. You have your data in that I sent you?
Oh, you know what? That's why. I did this first and I didn't do the data first. That's why.
Oh, yeah, go to the chat. Yep, go to the chat and just hit the link in chat and it will pull up everything that you need.
Okay, let me go.
Did you get your data pulled up, Darla? Give me a thumbs up. Is that it? I can't hear you. You're muted.
No, I was lost too. I'm like, huh? I'm putting it in. I'm not getting it.
Yeah, I
So go
love
to the
yeah.
Zoom chat. There's a link for my Desmos.
See, it was on there. I saw it earlier, but I'm not seeing it now.
On the chat?
Okay, let me go around the chat. Okay, chat. Okay, there's the chat.
And you don't see the link?
It was on there. I saw it on there when you first put it up, but,
Okay, I'm gonna put it again.
and so it should put it right up on mine, right? There it is. Okay, I see it.
Yeah, for some reason it must have went away.
Okay. So if I click on this, will it,
Gonna open up your, it'll just open up Desmos again, and you should already be logged in, and it should have your data. So Darla got hers.
It helps if I use the actual keyboard for this, not the keyboard on my computer. Does that make
Oh.
sense?
That's
All
good.
yeah,
Yeah,
I have it now too.
okay. Yeah, I prefer my own keyboard, but everybody's different on if they'd rather just use the one from Desmos.
Yeah, because you have the X1, the Y1, and all those stuff filled in. So now then I go down and do this Y tilde one under it, correct?
Mm-hmm.
Okay.
Well, sometimes I have the problem with the X and the Y not going in the right spot. So then I use the keyboard meant for Desmos, and then it works.
Oh, awesome.
I don't know why.
It do what works for you, that's for sure.
Okay, so now I am showing the R squared.
Yep, so you need to click on the log mode box.
Okay, I'm not seeing a log mode box.
Underneath.
Hmm.
Above where it says R squared, there should be a little open box that says log mode.
I see a statistics with a question mark. I don't see anything that says.
Okay,
log.
above there, above the statistics, it should
Okay,
say log mode.
yeah, I don't have it on mine. Do you have yours?
Show me your screen. You want to share your screen?
Yep.
She's gonna share her screen for a minute. Carter, did you have a question, hon, that you wanted me to answer about a worksheet or something?
Yeah, I just had a question over worksheet 2.4.
Okay, what's that?
I'm just having a hard time interpreting like interpreting in context.
Teresa, your X and 1 is in the
Sorry.
wrong spot.
Yep, your X
Oh,
one,
you're right. I didn't do it up, did I? Gosh, that's probably why then. Okay.
not
thank
your
you.
Y one, your X one, go to the right. There you go.
Okay.
That's where I use the actual keyboard. In that lower left corner, it shows you a keyboard.
Oh, now you gotta delete it again. Now you got something else, and
Oh, it's something else. Okay.
now.
So erase it. Click on the keyboard.
Yeah.
Okay, press the A2. This is how I do it. Press on the A2.
What A2?
You see X, Y, A2, AB.
No. Go
Oh, okay.
Back. X, Y,
No.
A2, AB.
Okay, I got.
No,
Y1 with the
No.
tilde.
he doesn't know
Down
where to
on your
look.
keyboard.
Go back over. No, not right there. Go over to the right of your parenthesis and click.
Keep
Okay.
going.
Yep.
All right.
Now just go down in the keyboard with your mouse.
Okay.
Nope.
No, go.
Open it back up.
She's.
Oh, go into the keyboard. Gotcha.
You see the X, the Y
Yes.
to your left. See the A2?
Yeah.
Click on that. This is how I do it. Then delete it. And then type in your X and your. You have to
Well-
delete the 2 and then type in your X and your 1 off the keyboard.
You backspace.
Okay.
That's
And
one.
then hit your X and then hit your 1.
One.
There you go. There's your log mode.
Okay, now I see log mode. See, I wasn't seeing that before. Okay. So did I just click on the log mode and then
Mhm,
it,
yeah,
there we
and now your R
go.
shows up.
Okay.
Now you can hit your, down below, you can hit your keyboard so that goes away.
Yeah. Jeez, boy, that was a bunch of drama. Sorry about
That's
But
right.
that's how I find it.
that. All right, let me unshare my screen.
Okay, so they wanted us to go over what all these things are here. We'll move this along because I know it's after 8 o'clock. Okay.
Oh, I didn't realize, okay.
Okay, so A is 255.06. That is our y-intercept. Her starting value. Because it wants parameters. Parameters are for an exponential function, parameters are A and B. A is your y-intercept, B is your growth factor. So B is 1.0104. That's our growth factor. And then our relative change, we take B minus 1, which is 1.0104 minus 1. So our relative change is 0.0104 or 1.04% increase. So while they're finishing that up, Carter, on the interpretation on slope, I want you to tell me the who, what, when, and where of what's going on with our situation. So you have to know what your units are of your X and your Y. Do you have your course pack out and open? I always encourage that.
Yeah, I have it open.
So that was like lesson where we started doing slope, like lesson 2-3 or so, 2-3 or 2-4.
Yeah.
And we talked about how, so C is about the slope. We talked about how slope is your change in Y over change in X. So you need to identify the units. So the Y units are going to be exam percent
Okay.
over percent attendance. And you got from your model, right? You got some slope, but it's really a unit rate. It's whatever your slope is over 1. So we did this a couple times. If you go back into those sections, we've interpreted slope and a couple different times, like with our hamburger one, we interpreted slope. With the pizza one, we interpreted slope.
Okay.
Yeah, so take a look at that. I won't leave yet, but that'll get you going. Okay, ladies are caught up with me. So does everybody see where we no longer have 1.3% growth, what we had on the front here, right? Where we had in our first model.
Right.
Now, our current year's data tell us that we're only growing in population by 1.04%. So do we think this new one would give us a better estimate of 2015?
Meaning, more
Closer,
of an accurate amount, you mean?
yeah, because we said the actual amount was this 320 million.
Yeah, and that was the way we over predicted.
Right, so let's try to find 2015,
Okay.
what the prediction would be in the new one. Okay, so I'm in Desmos. I'm gonna go to my new and type in my new equation. Well, it just came up, but I'm going to type y equals with this new equation rounded 255.06 times 1.0104 parentheses x. So this is an equal because we're actually typing in the equation y equals. And I'm going to make, with my gear, I'm going to make a table. And then I'm just going to go to a blank spot and I'm going to type in 115 for 2015. So this new model predicts, oh geez, did I type something weird?
What's 115?
Oh, it's not 115 because we started at 1990. Mhm.
You
So
did
it should
115
be,
from the other problem.
I know, I'm trying to go back and forth. I'm trying to do too much. And it's getting way too late for me to think like this. 2015 minus 1990. So this is actually X equal to 25. And I'm glad we corrected that. So there you go. So 2015 is X equal to 25. So our new model is predicting 330 million, 330.35 million people. And I'll just go back to my paper so everybody can see what I wrote. So the new model prediction is this 330.35 million people, and it's much closer. And then we already did number 8. It said compare the 2015 estimate to the population. We already did that. And then 2050, I just skipped that one. Because it wants us to go do a predictor, like some predicting website online. If you want to go find one, you can. But we can see here, the older data was probably pretty accurate, you know, for the first 100 years, but then we stopped growing by that 1.3%, it lowered. So this 1.04 is much closer than the other. So it's probably even less than that, really. Any questions so far? So the key from this lesson is writing down how you're going to do your model for exponential, the y1 till the a times b to the x1, making sure that you check the log mode box. And I will have the recording for 2.8 up on Thursday.
There's no video Thursday, correct?
There's no live session on Thursday, right?
Okay.
So I will have, I'm going to make a quick YouTube video, like my YouTube video of 2.8. And then I think there's going to be 1 or 2 parts, and that'll be in my YouTube. And then I will put in our nighttime link where I usually have the link from the recorded video. It'll say link from the morning, recorded morning session, because I'm going to meet with my morning class at 9 a.m. And I'm going to probably go over some 2.8 with them. And then answer worksheet questions. And so I'll record that so that you're all getting the benefit of the worksheet questions that they're asking.
Okay.
Yep. Any questions from here? I was going to see if what questions Carter has still. Oh gosh.
So I will watch for your videos and stuff then. If I have any questions, I will shoot you an email.
Okay, I'm probably not staying up tonight. I'm like exhausted. I've been grading and teaching since the morning. I don't know. So I will, I'm gonna try to get up early enough to make the 2.8 videos tomorrow before I go to class. So they'll be up at some point tomorrow.
Okay. Well, have a good night. Get some
You
sleep.
too. And I'll see
Bye,
you
Darla.
all next Tuesday. And
All
All
right.
right. Bye, Teresa.
See you guys.
bye,
Yep.
Carter.
All right. Carter, she's all yours.
You can stay if you want, Darla.
Okay. I'll put me on mute.
He asked good questions, so. More
Okay,
questions?
so I found like where you know about the y over x and then over like 1. So I found that page, but I don't know, I'm still like having a hard time like interpreting it, like on like what to say. Like I
Okay,
have like I found like I found all the numbers on 2.4. I just having a hard time like saying what they are, I guess.
okay, so let's go back to, because I don't want to totally give it all away. So let's go back and look at examples where we interpreted slope. Okay, so for example, in 2.3 on page 164,
Mhm.
we interpreted the slope of the car. So I had my slope over my 1 and my units in the denominator, which you would have with like your percent attendance and all that.
Yep.
And then it's going to be almost identical, but it's just going to be your story, a different story. So this one just says with every 1 increase, you're going to have the same thing. So with every 1 increase in years, because this one, the denominator was years. You can't see it, but it says, we can expect, and then we're not talking about the car's value anymore. We're talking about the grade on the exam, right? So we can expect the grade on the exam to increase or decrease whatever your slope value was. So it's going to be something with, as your attendance grows by 1%, right? Then what's going to happen with your exam grade using the numbers that you came up with your model. And it's not a big change, right? It's like 0.49% or something.
Yeah.
Yeah,
What page is that?
it's 2.4.
Well, I see it, but oh. I meant in the book.
164.
That's what I'm trying to find.
Yep. So maybe on your 2.4 worksheet, you just jot down that page. 164 is a good reference. We did it and we did another one on page 173 with the pizza. We did a really good representation of slope on number 6. And we talked about the y-intercept, I think, as well. We talked about the slope on number 16 right here on page 176. I'm sorry, 175. Oh, here's another good one on page 178. We talked about the slope there for the BAC. If you did an extra problem, you could go back and watch that video. We didn't do it in class, but I did make a video for that. So you could go back and watch that one. So there's lots of good examples of slope interpretation. And it just is kind of like the more you do it, the
easier it'll be to understand.
yeah, the more, and some of the ones make more sense to say. They feel natural, like, oh yeah, every pizza that we buy, it costs $9 more. I mean, that's a natural conversation. But when we go, oh, every 1% increase in attendance, we expect our grade to grow by 0.49%. I mean, it's like those numbers don't even really mean anything. But I want you to practice writing it.
Thank you.
You're welcome. Is that the only thing you had?
Yeah, that was like the only thing giving me a hard time. So
Good. Look at you go.
sort of like that. Thank you.
You got this, Carter. You got this. We'll see you on Thursday morning, hopefully.
Wait, I thought there wasn't a Zoom on Thursday.
So I'm not doing a formal Zoom, but I said this morning that I will be on there. I'm at 9. Probably can't stay maybe like till like 10, but I'm happy to do any of the lesson 2.8, that you want to work on, or if you come with questions on worksheets, I'm happy to do that because I'm going to record that hour and I'm going to put it on I'm going to put it in the morning session. I'm going to put it in the afternoon session. I'm going to put it in JetNet for everybody to see.
All right, I'll probably be there then.
Okay, great.
Then can I upload I can upload like my Desmos that I'm doing for like this worksheet
Yep.
to like
so- Yes, sir. So any of the problems that you do in Desmos, if you can name them for me, you can either do multiple problems in one Desmos link, or you can upload a couple Desmos links if you want. But just make sure
Okay.
you upload them using that upload link. You know what I mean? Don't copy the link with your browser and paste it in. You want to actually go to Desmos, click on that link thing, you know what I mean? And use that link and you upload it like I explained in class.
Okay,
Okay,
thank you.
you're welcome, dear.
Have a good one.
You too. See you Thursday.
All right. I will see you next week.
Okay, Freddie, let me know if you need help with anything.
All right, will do. Thank you.
Okay, bye, dear.
Bye-bye.